The Manila Trench extends for over 1,000 kilometers through the waters of the South China Sea, from southern Taiwan to Mindoro Island in the Philippines. This impressive geological structure sits in one of the most tectonically active regions on the planet, embedded within the famous Pacific Ring of Fire. Historically, this area has been the stage for devastating seismic events, although detailed records are scarce when compared to those available in Japan. The uplifted coral terraces along the western coast of Luzon serve as silent witnesses to ancient earthquakes that dramatically altered the local landscape. Geological evidence suggests this region experiences major seismic events at regular intervals of 250 to 400 years. These natural signs indicate that earthquakes with magnitudes exceeding 8.5 have already shaken this area in the past, leaving permanent marks on the coastal geography. The formation of elevated terraces demonstrates the destructive power of these phenomena, capable of raising or sinking land masses within minutes. The recurrence pattern identified by scientists suggests the next major event may be dangerously approaching. The Manila Trench functions as a subduction zone, where the denser tectonic plate of the South China Sea dives beneath the Philippine Sea Plate. This movement doesn't occur smoothly or gradually, but through an irregular and violent process. Currently, the plates are locked in a position of extreme tension, continuously and dangerously accumulating energy. This situation creates what geologists call a megathrust fault, capable of generating earthquakes and tsunamis of catastrophic proportions. Comparison with similar events around the world reveals the true dimension of the danger. The Sunda Trench, responsible for the devastating Indian Ocean tsunami in 2004, shares worryingly similar structural characteristics with the Manila Trench. Scientific estimates indicate that a sudden release of accumulated energy could elevate the seafloor by up to 10 meters, 33 feet, displacing massive volumes of oceanic water. This dramatic elevation would generate gigantic waves capable of striking densely populated coastal cities within minutes. In recent decades, the region has recorded a series of moderate tremors that, while not catastrophic, have drawn the attention of global specialists. The magnitude 7.1 earthquake in Mindoro in 1994, followed by another magnitude 6.2 in Pangasinan in 2006, served as somber reminders that the area remains geologically active. These events occurred along smaller faults or within the subducted plate, reinforcing the theory that the main fault is still locked in accumulating dangerous tension. The absence of activity on the main fault is ironically more concerning than reassuring. At the end of 2024, a sequence of offshore tremors near Ilocos Sur and a magnitude 5.6 earthquake in Ilocos Norte reignited concerns among the international scientific community. This increase in light seismic activity was accompanied by records of slow slip events, movements between tectonic plates that occur over days or weeks without being perceived at the surface. These subtle phenomena may signal that the system is approaching a critical threshold, similar to what was observed before devastating earthquakes in Japan and New Zealand. Slow slip events function as potential precursors to major ruptures, serving as early warnings of tectonic plate movement. Data from GPS sensors and seismic equipment suggest growing pressure along the main fault of the Manila Trench, dangerously increasing tension between the involved plates. This progressive energy accumulation represents a geological time bomb of unimaginable proportions. Scientists constantly monitor these signals, knowing that each small movement could be the harbinger of something much larger. Experts warn that, based on accumulated energy, the next major earthquake in the region could reach magnitudes between 8.8 and 9.3. An event of this scale would rival the 2011 Tohoku earthquake in Japan or the 2004 Indian Ocean tsunami, both responsible for catastrophic human losses, massive infrastructure destruction, and global economic impacts that lasted for years. The potential magnitude of this future event puts millions of lives at direct risk. A worst-case scenario envisions a rupture extending from southern Taiwan to northern Mindoro, with the seafloor experiencing uplifts or drops of up to 10 meters, 33 feet. This sudden movement would displace immense volumes of oceanic water, generating a tsunami capable of striking the western coast of Luzon in just 10 to 15 minutes after the initial event. Cities like Subic, Dagupan, and even parts of Manila would be among the most vulnerable, with virtually no time for adequate evacuation. The speed of wave propagation would make any effective emergency response impossible in these coastal areas. The giant wave would then travel across the South China Sea, reaching Hong Kong, Macau, southern China, Vietnam, and Malaysia within hours. Simulations conducted by Taiwanese and Japanese scientists show that such a tsunami could produce waves exceeding 10 meters, 33 feet in height in the Philippines, and up to 5 meters, 16 feet, in southern China. With so many densely populated areas and critical coastal infrastructure at risk, the human and economic impact would be absolutely devastating. The interconnected nature of the global economy would exponentially amplify the effects of this disaster. The risk extends far beyond the Philippines' borders, constituting a regional threat capable of affecting millions of people and generating lasting global repercussions. Major urban centers like Manila, Ho Chi Minh City, and Shenzhen concentrate millions of inhabitants in high-risk zones where rapid response would be extremely difficult during an emergency. These urban centers also represent fundamental pillars of the regional economy, meaning that the effects of a seismic disaster there would be felt worldwide through disrupted supply chains and commercial collapse. Geopolitically, a major disaster in the South China Sea would trigger massive international response efforts in a region already characterized by significant strategic tensions. Port closures, supply chain collapses, and trade disruptions could paralyze industries on a global scale. Recovery would take years, with long-term economic and political consequences that would reshape the regional balance of power. Global economic interdependence would transform a regional natural disaster into a crisis of planetary proportions. Despite the evident risk, preparedness remains insufficient in many countries bordering the South China Sea. In the Philippines, the Institute of Volcanology and Seismology has invested in GPS and seismic monitoring, but still faces significant limitations in coverage of underwater sensors and pressure-sensitive equipment, essential for detecting early signs of submarine seismic activity. Although collaboration exists with Japan for predictive modeling and data exchange, coverage remains inconsistent, especially in the deeper parts of the trench and in neighboring countries like Vietnam and Malaysia. The absence of a unified tsunami warning system throughout the region represents one of the greatest weaknesses in the current preparedness system. While some Philippine cities conduct evacuation drills and have emergency plans, many coastal communities lack even basic information or infrastructure to respond adequately. In places like China, Taiwan, and Hong Kong, risk modeling efforts and civil defense integration exist, but public awareness remains dangerously low. Unregulated urban expansion along coastlines and lack of investment in containment and evacuation infrastructure dramatically increase population vulnerability. The inconvenient truth is that despite all the scientific knowledge we currently possess, the most crucial element is still missing: effective political will and international cooperation. The Manila Trench doesn't recognize national borders. Therefore, it must be treated as a global priority that transcends local geopolitical interests. We urgently need to invest in advanced research, state-of-the-art monitoring infrastructure, integrated alert systems, and, above all, massive public education about natural disaster preparedness. Time remains uncertain, but the warning signs are all clearly present and gradually intensifying. Ignoring these warnings from nature could result in an incalculable humanitarian and economic price for the entire region. The international scientific community continues to carefully monitor every tectonic movement, every small tremor, every sign that the sleeping giant may be awakening. Adequate preparation today could be the difference between a devastating natural disaster and a tragedy of historical proportions that will mark future generations. If you found this geological analysis crucial for understanding one of the world's most dangerous seismic threats, please share this video with your friends and family. The Manila Trench doesn't discriminate by nationality. This is a regional risk that affects millions of people across multiple countries. Hit the subscribe button and ring the notification bell to stay updated on the latest developments in geological science and natural disaster preparedness. Your engagement helps us reach more people with this vital information. Leave a comment below telling us which aspect of the Manila Trench risk concerned you most. Was it the potential tsunami height, the lack of regional preparedness, or the uncertainty around timing? Here at Geology Info, we transform complex scientific data into accessible, responsible content that keeps communities informed about the natural forces shaping our planet. Knowledge is the first line of defense against natural disasters. Stay informed, stay prepared, and we'll see you in the next video where we continue exploring the geological forces that impact our world.